go on break?
What?
Alright, before we go on break, I want all your notes open. Right. Notebook open, everyone.
Hey, I kind of felt listening when you talked a lot.
Yeah.
Okay. The next thing I'm going to talk about is one question I've asked you a while ago. That is, why is this number a decimal?
Because it's an average.
And then that's what we're going to talk about now. Okay? I'm going to help you understand that this number. By the way, raise your hand if you remember what this number represents. Atomic weight. Okay. Jonathan, you want to tell us what it means?
Sure. The atomic weight is the average number of protons and neutrons in every stable isotope of the atom.
What does that mean? What do you mean by average, weight of the protons and electrons? What does it mean?
Like you just average out the number of neutrons and protons in every isotope.
Okay, sure. Alright. Alright. What did I tell you? What did I tell you about atomic weight? Anyone? So I told you atomic weight is simply the sum of the weight of proton plus neutrons, right? Okay. So, and right? Follow along, okay? Alright. You know that protons are integers. They're either 1, 2, 3, 4, right? Neutrons are also integers, 1, 2, 3, 4. And so so the next question is, why is there a decimal there? Okay? And it goes like this, okay? Before I get into this part, right, I want to help you out and figure out an example to this kind of thing. Okay? So pretend you're trying to figure out your grades, okay? Your grades.
You do the
I
average.
already did that.
Okay? Your grades probably has some assignments, tests, quiz, exam. And just like how your actual school, right? Say, okay, your assignment is 20%, test is 30%, and 30%, and whatever. 20%, okay?
What?
Does that make sense?
That's just,
Yeah? So, when it comes to finding out your own grades, which I hope you all can do, what do?
I find the average.
So you get what's called a weighted average, okay?
Yeah,
You
but
get-
obviously for this you're not finding the just average.
You want to find the weighted average. Okay? So weighted average means each of these worth a certain component. And they don't some are worth more, some are going to have a bigger impact on your grades, some aren't.
It's like assignment times 20 plus test times 30 plus quiz times 20 plus.
So what happens is, say you got a 95 on your assignment, and you got a 90, and you got 100, and you got 80. So that once you have these numbers, okay, which might not be realistic, but okay, once you have these numbers and you know the percentage that these are worth, you have enough to figure out your actual grades at the end. Yes? So what would you do?
you find the average.
Not just the average, not just the average right there. Okay, so if you said the average, how would you do it?
You add it all together and divide by the amount.
But they're not all 25%. Some are worth more than others.
Yes, so you see, that's what this weighted average means. You don't do just add them up divided by 4. You gotta worry about these percentages as well, because you getting 100% on your exam is gonna contribute more to your final grade. Over here, let's just change this up a little bit, okay? Let's say this is 45, and this is only 5%, okay?
Well, then you get a really good grade.
So you
Yeah.
get, exactly, so even though your quizzes are not as good as your exams, but the quizzes overall only makes up 5%, right? So it has a greater pull. Your exam have a greater pull, greater contribution to your grades. And that's what this idea of atomic weight is, exactly like that. What's called a weighted average. So what you will have to do is, to find your grades, you take this number times this number plus this times this plus this times this plus this times this. And you get your grades, right?
Also, is that easy?
That's how you do the average, the weighted average. So it's not simply taking 4 numbers, multiply, so addition, divided, no. It's you do 95 times 20% plus 90 times 30, so on and so forth. You add it up. So which brings to the next question. Why do you have to add it up? Why are these percentages here in the first place? Like, think back to this idea.
Bro, that's how much it counts.
Yeah, that's how you would correctly find your grades.
Bro. And then,
This is not anything to do with chemistry. This is just for your sake.
Another thing they never teach in school.
Yeah, they teach it. I mean, not at my school, but like
No, they teach you how to do average in grade 7, but they don't teach you how to do
grade
grade 7.
7.
They haven't taught you this?
No, you already know.
Does that make sense though?
Yeah.
I didn't
Dude,
do
I learned
that.
average when I was
Okay.
in grade 2.
We knew that
So-
in one.
Let's come back to this.
Good for you.
Now, there's more to this story about atomic weight, okay? Erase this. Because it deals with percentage, just like your grades. Okay? And it goes like this. Sometimes certain elements don't just have a fixed number of neutrons. Right? That's just how they are. They have variations. Right? So remember we said the number of protons determines the identity of the element. Number of proton, keep that in mind. So number of neutron, it can vary. Okay? Sometimes you'll find a few more than normal, sometimes you'll find a few less than normal. But they're still called the same element because the protons doesn't change. Okay? So that's exactly what we find in nature. Some elements. Tell me now, right now, we're looking down your periodic table. What's the neutron for carbon? What's the number of neutrons?
6.
for carbon?
6.
6?
Yeah. No, 7, 8.
6.
6.
How'd you get 8? How
That's,
the hell did you
you
get
did 12 minus 6.
12 minus 6 is
So how
7.
many protons is it?
6.
6.
6 protons.
12 minus
How many
6 is
neutrons?
7. Good math.
How many neutrons, guys?
6. I mean, 10.
Good math.
All right.
Good math.
Quick
So,
math.
in
Everything
total,
that's in a box.
inside the nucleus of the carbon, you have 12, right? 12 particles, subatomic particles. We call this type of neutron carbon 12. Okay. So I'm just using carbon as one example here. It's carbon 12. Now, like I said, sometimes within one element, you'll find specific atoms with different neutron numbers. Alright, so you'll find another element might be also see 6 protons, but it might have 8 neutrons. 2 more. 2 more than what would normally be. So that's 14. So this is still carbon. Still called carbon, but it's called carbon 14. And so now you have siblings of within one element. Okay. Now, as it turns out, now this is starting to look more like your grades. Okay. So in nature, scientists did estimation to try to find out, okay, of all the carbon atoms there are, how many percentage is of this type, how much percentage is of this type? So say, okay, so carbon C12 is say 98%, and then, which is a very abundant, right? Almost all of it is C12, but it just so happens the rest 2%, it's the other one, C14. Okay. Does that make sense? So inside the body, because we have a lot of carbon, right, in your body, most of them are in this format of 6 neutrons, but just a few here and there is C14. And the ratio between the two are just very random. Sometimes you'll have a lot of this, sometimes you'll have a lot of this. Okay? But overall, in the entire universe, that ratio is about fixed. So it's like, I'm not sure if it's exactly 98 or 2, but yeah. So certain variations are a lot less common than the other variations. Make sense? Your homework, okay, you can Google carbon-14. You can find out there's a lot of, we rely carbon-14 to do a lot of things. I'm going to get you to find out what they are. Okay? They serve a specific function, allows the scientist to do something.
One use for carbon-14 is boring students inside classes.
Let me finish. So, how would you find the average then now? Let's come back here. So, I told you atomic weight is the sum of these two numbers. So now all of a sudden you get 12. So to get the weighted average of the atomic weight, how would you find the atomic weight?
Multiply by 0.98
Okay, multiply by 0.98, and then what?
plus 14 times 0.02.
And do you get a decimal?
Of course.
Try it.
What are the numbers? Let me see.
All right. Let's calculate this. Times 0.98 plus 14. Right, so you get 12.04. I think I came pretty close to the actual number on your periodic table, is that right?
12.01. You weren't close
Okay,
enough.
so I was a bit off on my percentage, but it's roughly that
It's
idea.
by 99 and 1%.
The point is not the percentage, the point is you try to understand how you can get a decimal from. Now, can other elements have more than 2 variations? Yeah, you could have elements with more than 2 variations. So there are 3 possibilities. Some even can have more. Their neutron can have, many possible numbers. Does that make sense?
Kind of.
So this value you're seeing is what's called a weighted average. Okay. That's why you all of a sudden start to see decimals. Now, because this is as best of a representation, the best representation for the weight of all of these. Because you don't want to show 2 numbers, but you want to show 1 number that represents all of them. The best way to do it is by doing a weighted percentage, weighted average. Okay. But for the sake of you doing practice questions, I told you to round off the numbers, right? That generally works. So generally you will be dealing with, because this is so much more common than this one, if you were to round off, then it comes down to 12, which means you can safely assume the number of neutrons for carbon is 6. 90% of the time, or 98% of the time, which is quite often. Right? Okay. But now you know the other piece, that it's not actually just 6 neutrons, there are 2%, very small amount of carbons that are kind of special with more than 6 neutrons. Not only is this only the case for the carbon, it's really the same case for every single element on your periodic table. Okay? Right. So although, you know, in your school, right, as you go to grade 9, grade 10, as you go to high school, you're going to involve learning about finding out the neutron numbers, right? Now you know better. Now you know Enzo told you, no. It's not just 6, right? It could be more, or it could be a different number, depending on exactly what the atoms you're looking at. Okay? Some atoms in you, some carbon atoms in you are kind of special. Which means they're kind of heavier, right? Because they got 2 more neutrons. Heavier atoms. Okay? Alright, questions? Alright. Let's take 10 minutes break.
About like where we're heading and the documentary.
Oh, the boundary line.
For that documentary? Yeah. Okay, good.
Okay.
Thank you.
Alright, if you have any questions, you just email me or
No problem, thank you.
I'm sorry. This is too loud.
Yes.
I'm sorry.
Not too loud.
Okay. Not too loud. I'm okay. It's a little loud because we like
I don't know,
this.
I have like math out and math. Yeah.
We like music.
I used to be
You want gum? Are you allowed to chew gum?
I don't want to.
You don't want gum?
like, how do I get up? You can die. You can mine up, can't you? I think that I can, but I don't want to destroy this game.
Why do you suck at this game now?
Frick. I can't find waterfalls. I'm supposed to water.
Press start.
What? No, I hit that part.
It's so small though.
Well, I
There's
really
a
hate
coin duplicating glitch in the game.
Yeah, I know. I have like a full ball full of hats. Yeah, exactly.
No, return it.
I basically repaired all of my tools into the legendary ones, or like whatever the best.
I want to do practice on
Yeah.
after this.
Well, Dad, I see all of these stuff.
You said I'm not good, huh?
You are bad. See?
This kid's like,
That makes sense. Okay. I'm just trying to find the damn. Wait, I only have 5 damn
No,
stuff.
yeah,
I'm screwed. I'm screwed. No, you're not. Are you screwed? Oh, you don't even have a house yet? This is on. Oh, I'm so used to doing 40 damage. I'm so used to doing like 200.
No! I need that.
Yeah.
well, I love
Like,
that.
dude, what's your favorite weapon in the entire game? This? No, my favorite is like the best one in the game. I forgot what the name is. I have to carry like P or AG or what. Hey, just for yeah, PE. Hey, A is that's probably Flare.
Go drum.
I don't think.
No! I keep failing.
Do you mean the one that you get from Duke Fishron? This one where like it sends out bubbles?
No.
I have auto on.
Not that one.
What auto?
Since that is this is gonna be closer to freezing. Hopefully, yes, one of them.
What hit that part?
I don't think I ever failed that one before.
Main thing is the.
No, that I was that guy. No.
Yes! Magic mirror.
Finally found the mirror.
I have like 20 mirrors. Yeah.
They sell for a good amount.
Yeah. Oh my god. I feel so much fun. Oh crap, it's the jungle.
Oh. You probably have
It's
Go
so
back.
dangerous.
Go ahead.
I'm
No!
That's not
Victoria.
it's decent.
No.
My friend's one
I brought a charger for 67%.
Bro, yeah, I know. I haven't played P for a minute.
That's a kid, right?
I know. I used okay, I'll tell you one thing.
Hey,
I'm
you're right.
recording all this game, but I'm actually a pro.
What do you want to do at your house?
Wait,
Oh, crap.
we're almost done.
Again?
This
There's
guy's
nothing to do.
fast.
Soccer.
I'm tired.
Fine.
No, come on.
Excuses.
You got hard to
I am
get
tired. You probably got way more sleep than me.
Yeah. Go, Brett.
What the hell?
Go, Brett.
You get one.
No! Why did I jump? You get so nervous when you pass your score. Don't jump.
Oh dang, I found it in corruption.
Jump again! Quick, jump
Not
faster!
fast. There's nothing at that part.
You have to jump
I
faster.
need that part.
Was it the theater of the world?
Yeah.
Fred, how am I supposed to get there? Okay.
How did I miss that
Let's
jump?
go. Don't fall into a hole. I hate how when you're fighting the gold flesh that like if you use the next mirror you can die. Basically. Like one time you just have to bro, just saying, okay.
Jump faster,
When
jump
I
faster,
fight
jump
gold
faster,
flesh,
jump!
I usually have like a helmet.
Don't jump!
I just like ready.
Since I like living in the hell or
This is
like
bad,
super
man.
high.
You always tell me not to jump.
I just have this gigantic bridge that stands in one section.
Wait. Try testing this out.
Simple, quick.
Just had one fall into the hole.
Wait, if you came out of a desert, in a world with, oh man. I just got to myself right now.
Why did I jump?
No, deserts are kind of rare. No, deserts are pretty common in the no, it's the one and two. Yeah, no, it's ice. Some of them are. I mean, I like ice more personally. Personally, I like.
Well, I don't think I can play
Because of the
Monsters. My mom's gonna take a long time to come here.
Yeah,
What?
that's true.
Why is it not
But
jumping?
if you
Why is it
want
not
to have
jumping?
it,
I think I used to have ice with the deserts. I don't think.
Probably just the Indian on your phone.
Wow, the Indian.
Okay, oh yeah, that's the.
Wow.
I'm sorry, man, if I find the damn water book.
Actually, my phone is actually really good. It's actually like really good. For some reason, my mom actually trusts me with this super good phone.
Most fun.
I don't know how.
Shadow.
Limited edition equals that equals.
I remember
It's capable of 4K camera, you know? I mean, 1080.
just say. Okay. And then I reforged it with all of my platforms. Did you fight the wall?
Is your camera full
Okay,
4K?
try it. You go to
Is it still recording?
No.
Right now?
Yes.
What?
Okay, at least I got a damn key somehow. You know what?
Why do you always fail? You should practice. Let's do practice more.
Fun.
Please, I don't want to lose my.
I don't like the music.
Yeah, you did it.
Mike, you don't use songs if you
I turn off the music.
Actually? Yeah. Unless you go that far into the dungeon, then you lose everything. You never see that? Okay, you know what? I actually know. I always thought it only affects you. I always thought it affects you.
Grab it.
Oh no.
I'll do it.
I can't mind. This world is so bad.
No.
Let's try.
I want to do this. Just let me get this out.
Okay, everyone.
Oh my God.
No more 3 minutes. Now, put your phone away. Your
Yeah, you're
iPad
so
away.
good at this. You're so good at this part.
Yay.
No, you gotta be hard.
Yes.
Yeah, let me grab
finally
it.
got it.
Oh my God, Kevin. You thought.
Alright, back to your seat, everyone.
Please, just 2 more minutes.
No 2 more minutes.
What?
You dropped over it. That's your fault.
Guys, put your phone away. Alright.
Give it to me.
Fine.
Okay. Alright, so iPad off your table. iPad off.
She's still playing.
Hey. Guys,
Take it.
Just take it.
okay. So this part is this is going to be about talking about compounds, right? We finished off learning about ions. What are the 2 types of ions again?
Compound.
Cation.
Good.
Yeah.
Which is which?
Cation is positive.
Good.
Cation is positive, I think.
Cation.
And so the first type of compound we're going to learn is called ionic compound. So it's going to involve ions, right? And there is okay, let's go down, skip these. And so now, quick review why we now understand why the noble gas. By the way, who is doing noble gas for presentation? Okay, so Pearl is going to, for her presentation, she's going to tell us, or she's going to re-emphasize this part, the fact that they're not reactive, okay? What you should know by now, the reason for that is they don't need any more or less, they don't need to lose or gain electrons. They're happy, they already have full valence. Okay? So that's one of the reasons when you study chemistry, you will not run into these elements all that much. You just don't need to involve themselves with other elements. Okay? Okay, so let's go to the slide. We are going to, this is an overview of here. So we're going to focus on this type of compound, ionic compound, for now, right? And like I said last week, ionic compound really is about the transfer of electrons. there's one party that gives electron and there's another party that takes electrons. Okay. And by doing so, by either giving away or taking the electrons, both parties becomes ions. And the ion charges are opposite of one another. One party becomes positive, the other party becomes negative. And the opposite in charge, the difference in charge, is the reason why they come together. Because opposite attracts. Okay. Right. This is what we saw last week, right? This is the visual for like literally finding out, okay, what happened. Here, this electron will go over here, and in the end, you'll get this thing. And I remember drawing that on the board for you guys. So, let's check out this element here, sodium. Okay. And right now I'm going to show you, first of all, the graph, the drawings for how ionic compound forms. Okay. I'm going to use the Bohr-Rutherford diagram. This is the most details. Okay. So tell me now, how many protons does sodium have?
Protons,
Neutron? 20?
12.
12.
Oh, okay. Alright, so now you know the 12 is not really, you now know there might be a different sodium that have a different neutron number.
14.
No, it doesn't always have to be 14. Sometimes it can be even less than 12. It's not always going to be 14. 14 is just the example we had for carbon. Alright, so here you go. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. Yeah.
Is it draw like the range in 8 different parts, or draw like two pairs?
Then measures or
What do you think?
I think that doesn't matter.
Doesn't matter?
Yes.
Why doesn't it matter? Why doesn't? First of
Still all 8 points.
no, there are points, but they represent an electron.
Which one is right? This or that?
9 is right.
So don't you put 2 pairs in together?
No, don't do it. And once again, the reason is because the electrons are spread out.
Yeah.
They do not attract. Okay. All right. Chlorine on this side. Chlorine, how many protons?
What?
17.
How many neutrons?
18.
well, that's in my group.
It's a nasty.
It's a salt.
Yeah, I knew that.
Nazis.
All right. This is the electron that's being transferred over to here, and so afterwards you will get. So I know it's tedious, but this allows you to visualize what's going on here. 2, 3, 4, 5, 6, 7, 8. So this is sodium plus, because
It's only plus.
you no longer have the last electron there. So to show the charge, we gotta put brackets. And now same thing for chlorine. Now that chlorine received this electron, it's going to be negative charge. 17 positive, 18 neutral. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 2, is the special electron that now is in chlorine. Okay. So this compound is now like this. You now have somehow made these two come together in a bond. Okay.
That means I got this one right.
Alright? That's what that is showing you. So like this slide says, it involves a metal and a non-metal. Which means from your periodic table, you can start creating ionic compound by taking something on the left side, right? Because all the metals, most of them are on the left. Taking something from the non-metal group on the right side.
Yes.
Smash them up, and you can make a compound.
Magic.
Oh.
Alright, so that's how that works. That's ionic compound. Ionic compound can also involve more than 2 atoms. This is a simple case. You just need one of each, one of either metal, one non-metals. Sometimes it's different, right? Sometimes you get into this situation, right over here, where it involves 3 atoms. Yeah, so sometimes there's not only 1 electron being transferred, there's 2. Or it could be more, it could be 3, 4, 5, 6. Okay, so here you go. Magnesium loses 2 electrons, losing one chlorine atom, losing another electron to another chlorine atom. So we get this thing. You can still draw this over here in this way. It looks huge and it looks there's a lot of lines going, a lot of circles. So we're going to save the trouble of doing that, but that's the idea. Right? This is the more simplified view. And so this example, you see in total 3 atoms, right? You have Mg2+, which is looking like this. Notice I'm starting to draw the Lewis dot diagram. Chlorine, 1, 2, 3, 4, 5, 6, 7, 8. Chlorine here, 1, 2, 3, 4, 5, 6, 7, 8. Lewis dot diagram.
That's really hard.
Alright, so I can still draw that, but for time's sake, I just draw this one. Okay, so now get rid of this. Magnesium chloride. Now you can start to understand the 2 would just represent here and here. 2 atoms. And you don't see any numbers here because if you don't see any number, it just means you imagine there's a 1 down there. Okay. So if you ever need to represent 1, you do not need any numbers. Okay?
Obviously.
Alright. Let's go down here. Alright. By taking in and giving out electron, both the metallic and non-metallic achieves completely filled valence. Okay, completely achieves. Both sides, both parties are okay. Here, full valence. Here, full valence.
Wait.
And so, they all of a sudden, their valence starts to look like the noble gas. Right, their noble gas have the same valence as the full valence. Okay, moving on. Okay, so keep in mind this is the word here I have highlighted. This kind of force that draws the 2 atoms, the 2 ions together, is called electrostatic force.
Electrostatic
Okay, I want to see you start writing this down, please. Okay, so it involves two charge, one the negative charge, another the positive charge. And the charge difference creates a force, and that force is attractive force. Okay? And it creates this bond called ionic bond. So just like gravity, which is a type of force, this is also a different type of force. Okay, this is also like gravity, it will pull things towards one another. It's just that this kind of force applies to atomic level, right? Applies to very small scale. Question? You guys okay with electrostatic force? If you're confused, think about gravity. You know, gravity pulls us pulls us down. No, but the idea is the same. The idea is the same. So gravity, just like this one, it creates a traction force. Okay? This is why, like, you know, apple will fall onto the ground. You can stand here and not floating in the air. The same thing with these, okay? This is why the positive charge will then be drawn towards the negative charge. And when they come together, there's a bond. And they stay together. Once they come together, they stay together. Between these two atoms, there's a bond, and this bond is called ionic bond. Okay, this is what I drew here.
I don't have to copy it down. I can take a picture.
No, Kevin, I want you to write it down.
What?
Yes, you have to write it down.
Because you'll learn better.
Yes.
Yeah.
But I can review at home.
I don't trust you can review at home.
Yeah, that's what I do. And plus, it's proven that if you write something down instead of taking a photo of it, you typically remember it for a longer period of time.
Yeah.
But I first read it.
Okay.
That's not effective enough. Exactly.
All right, next slide.
Okay,
multiply.
good. This is what I wrote.
Hey,
Good job.
so now we haven't got into naming these things yet. I just shown you these symbols and writing it together. I haven't actually shown you how to like call this compound, right? So
This chemical bond.
yes. So remember, chemical bond is a bigger term and it includes three types of bond. And ionic bond is one of the types of chemical bond. Okay. All right. This is the drawing, same thing as what I have here.
Oh.
Now,
Just to the Na to have a one alter valence, you have to move to the C.
yeah, exactly. Not CIC.
Also, salt is called sodium chlor something.
Yes, we're gonna try not to worry too much about this for now, right?
Can you pass the sodium chloride?
The names, are we gonna cover how to call these compounds later on?
So Cl becomes 17 protons, 18 electrons.
Yes, you're right, 18 electrons.
Oh.
Can you pass the sodium chloride?
All right. So, like I've already done for you, how do you draw these Lewis dot, or rather for, here is an example of the Lewis dot. Sorry, this is the Lewis dot. All right, I can draw this one Lewis dot as well.
At least. The 4 with 4.
What's that for?
Okay, this is the Lewis dot, which is the same as there, right? I put them side by side so you can refer to it. Okay, now it's your turn. Now I want you to start drawing
What?
a few examples, right? It's just to get you practice them. Practice drawing this one, right? So I'm gonna write a few things. Now you can understand, sometimes you'll see numbers here. You know, okay, it's gonna be two of that kind of element. So, here's the practice, magnesium oxide. Right, this is one compound. Try calcium, this one.
So you make ethane and oxygen. This is
Oh, there's a spider.
So now you're trying to, okay, start with the first one.
Except for the
Guys, trying to do the exercise. Draw for each, draw the Bohr, Rutherford, and the Lewis dot.
What? What?
Yes.
What? Can you say the question again?
For each of the compounds I have here, draw the Bohr, Rutherford, and the Lewis dot diagram.
MgO.
Okay, and if you can't finish the other two, you do it for homework. Okay, so just start with one, this one, start with this one.
Homework is MgO. MgO is
No. Now you're drawing this one now,
Okay.
and you do the other two for homework.
Okay, MgO. Found it. This is hard.
It's not hard at all.
I'm trying my best.
What the heck is MgO? Why don't you even have
Magnesium oxygen.
I don't even have
Lucas, can you sit next to someone who has it?
Sit next to me.
Andrew has one.
Yeah.
I have two.
Yeah, so
I have 10 million
You know what?
because I have the internet.
I have a really messy one now.
Sit next to me.
anything.
Yeah, sit next to me. Yeah. I have a new button.
Me after you.
It's wrecked, so good luck.
I thought you said you had 10 million.
Yeah, I do. It's
So-
in my phone.
in case you're confused, you can look at the board. I have example here. You can look at the slide.
It's just magnesium and oxygen. I'm struggling.
All right, I will take it up, but I will give you a few more minutes.
Okay.
One, two, three. I forgot.
You can work it out with the
Oh.
person next to you.
I finished.
Also
The first one.
All right, just stop there.
The
if you
first
finish.
one.
Okay. Yeah, just
I
that.
only did the blue one.
It's sodium.
I did Louis dot.
I think I failed.
Where's magnesium?
No, you don't need to draw this step. Just draw that step.
Oh.
So this is like before they become a bond. This is right after they become a bond. Okay, so once again, guys.
Yeah, I
How
think
many
I
cells is this? Wait, we're doing magnesium.
So,
Okay, back to your seat. Alright, so I want to make one thing clear.
Oh my god.
This I have drawn here. This is not your final answer. Your final answer for Bohr Rutherford should look like this, with brackets on it.
Oh,
This
right.
right?
Okay.
Oh, it's mine.
teacher, is it cool? Just
Okay.
How does this even work?
Oh no. It just goes MG plus
Yeah, that's good.
and then see yours.
It was me.
How much sugar are you eating?
Alright, anyone need more
He
time?
doesn't get high sugar that easily.
Yeah, I don't.
I do.
You get hyper.
Is it?
Alex,
Oh my god.
you doing it? Why don't you put your notebook on your desk?
What time is it?
It's probably
Okay,
wrong,
so
but-
guys,
Enzo, what time is
you
it?
can take this.
Wait, Enzo, what time is it?
There's
Right now?
12 more minutes of class.
It's 10:48.
It's 10:48. Wow.
When does class end?
11.
Use your brain.
Oh,
How many?
I have.
I'll give you two, guys, shh. 2 more minutes and we're taking it up.
Can we just pick it up
Can
now?
I do the next one?
Yeah, you have to.
Yay, I like doing this.
Yo.
You like doing this?
I don't know why.
I like this one.
First
Be
out.
sure to draw Bohr Rutherford and Louis Dog, please.
Copper and
20. 20.
Steven, you're okay?
copper fluoride.
Kevin?
Yes, yeah.
And insurance. With insurance. Hey Benson, I think we're the only grade sixes in this class.
Doesn't matter.
We're so young.
Wait. When's your birthday?
I'm the youngest, probably.
Yeah, you are. What grade are you?
36.
I'm also.
Probably about
you are?
grade 8.
I'm grade 6.
You look like
You look grade 8.
And I'm
You're in
grade
grade
6.
8. You are in grade
I'm
8.
born 2006.
Well, that means you're grade 7.
Then what year
Are
are
you
you?
s-
Then what?
Oh my god.
Then what is your?
I'm grade 6.
Well,
you born
These
in
are
2018. When are you born? 19.
Yeah, now June is Bohr Rutherford. Now
Oh
June
wow,
is
how
Dog.
do you know?
It's
Guess
not
I'm
even
first
that.
try.
This one.
So you should be 20 something.
Louis Dog.
It was 18 plus.
Your math skills.
No, 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 I'm
22.
trying to show you
Should be
draw
22.
something like
You're
this.
actually
This
so
is
bad.
what's called a Lewis
No, I'm
dot.
actually really good at math.
I'm better than
This
him.
is this.
I'm better than
No,
him.
I'm better.
You
You mean you're doing SSAT
You're
This is
test?
called
speed
this
at
compound.
2018 minus
I'm
19.
Me too, I got that.
Me too, I got perfect
It
numbers.
was so easy.
It was so easy.
It's copy.
No, seriously, I got perfect on it.
Yeah, I got better than
No, I got
that.
98%. What did you get?
98 is not perfect.
The math I
98 is B minus.
No, it isn't.
I'm.
Yes, it is.
You got-
100.
No, you got 87.
No, that was not. You don't even know my score because I won't tell you this.
Okay, just sit down. We'll take it up.
I know,
Okay?
like, you know, the marks.
Okay.
Well, Jeffy is really
Back to your seats. Stop talking.
Hey, I need the other one. I didn't finish it.
Okay, Vincent, you can stop now. We're taking it up, okay? I'll write it out again for homework. So, magnesium, starting with Bohr Rutherford. Tell me the number neutron, number of proton first.
Number of proton is 12. Number of neutron is 12.
All right.
Yeah. This one, last one.
You still have
We'll do this one last one.
Oxygen, number of protons.
Oxygen has 8 protons, 8 neutrons.
Don't do it.
I split it in half.
You give it to me.
What's that?
Take it back. No, you don't deserve it.
Haha.
They would tell you want it.
Then you bite it. Got it.
Double check with your own answer.
2 bucks. 2 bucks. I got it right.
Make sure you have the correct number of electrons in these dots over here. Make sure the numbers here are correct.
I got it.
Let me see if I actually did it.
Peter, why is that wrong? I got it.
Also close.
Two. Told me five wrong.
Oh my, I messed up the.
Okay, so fix your mistakes.
That's it.
No, okay, fix your mistake. Remember how you did it wrong, why you did it wrong. Remember why this is right. Okay. Stare at this for a few more seconds if you need to.
Stare at, or I'll just take a picture of
It
it.
was too small.
Now make sure you got every pieces of things here correctly.
Wait, don't move. No one move.
So the first one is.
No one move.
Yeah, because
It's into OMG, so we just
No one cares.
no, you don't always switch them. You have to put this one first, this one second. That's the rule.
quick.
Okay?
What is a
The rule is you always write the metals first, the non-metals second.
Oh
Oh,
my
and
god.
the right side first.
Yes.
Okay.
Weird, that's better.
Try better idea.
Okay, next one is the Lewis dot.
Oh yeah.
Magnesium, this is, that's what it is, okay? Once again, the reason you don't see any dots here, because the outer valence electrons are gone. The only two valence electrons that supposedly should be there have now transferred to oxygen. That's why oxygen got extra 2. You can also try to use an X to symbolize these are the special ones. These are like new electrons coming from sodium. So coming from magnesium.
Teacher, so why is the neutrons, the magnesium, it's like no two electrons, why it's not 10 neutrons, it's 12 neutrons?
What's the atomic weight, Steven? Tell me what's the atomic weight.
Magnesium.
No, you're asking about oxygen, right?
Magnesium.
Okay, why is it 12?
Yeah.
Right, tell me what's the...
Oh, divide by 2.
No.
12, 24.
How do you find,
24 minus 12.
how do you find the number of neutrons?
Number of the valence. The,
So you see the weight is 24, something
no,
like
the
that.
atomic, we
Now you
minus the
see
atomic
number,
number.
atomic number is 12. And to find the neutron number, you have to take 24, which is the weight, minus the atomic number, which is 12. So that's why you get 12. Alright, that's it. For homework, you can write this down. Calcium chlorine,
Calcium, chloride,
lithium oxide.
That's up?
By what? By what?
More?
No,
I'll give you a few more, okay?
no. I don't think.
Wait, how do you do the two lithium?
Can I start?
How do you do two lithium though?
Let's switch it up.
You put 2 of them and add it together.
Are you
3? What's the 3?
What do you
3
think?
sulfur.
3 sulfur.
Wait, how do you do 3?
3 sulfur.
I
Oh,
wonder.
you do 3? That's for you to figure out. That's your homework.
God,
Yo, what the heck?
nice paper airplane.
Launched it like 1 meter.
Nice paper airplane.
I agree. The more you drawn it, the better it is.
What did you do?
Well, I basically trashed
That's
it.
your homework.
I finished.
Four
I just need one
Mine is
more.
worse.
No, 2 more. I mean.
That doesn't
All right.
work.
I was doing just
Wait a minute.
before I had.
At least if you're confused about the last two, at least the very least thing you can do is Google them. It's not a test. You can find out answers in any way you want.